Hello everyone. So today I am going to start Bayes theorem. B-A-Y-E-S Bayes theorem. So Bayes theorem, it is a part of the probability, So one question will arise in your mind. First of all, sir, in probability, what is the need of Bayes theorem? This will be the first question that will strike in your mind. If I am going to solve a question of probability, sir, then what is the need of Bayes theorem? Right? So I want to give you the example. Then I think you will better understand. See, suppose two bags are there. Two bags. Bag 1, bag 2. Two bags are there, right? In bag 1, two white balls and 4 red balls are there. Okay? And in bag 2, 5 white balls and 7 red balls are there. Got it? So, if I will ask you what is the probability of drawing a red ball from bag 1, then you can very easily find. You will write like that: probability of red ball from bag 1 is what? 4 by 6. 2 by 3. Very easy. It is very easy to find the solution like that. If I will ask you what is the probability of getting a red ball from the second bag,
7%.
then you will see that red ball from the second bag. Probability of red ball from the second bag. Then again you can say, what you can say? The answer will be 7 by 12. It is easy, right? But if I will ask you, whatever the red ball you are getting, what is the probability that that ball is drawn from the bag 1? This is the question. I have drawn a red ball, but if I am asking that what is the probability that whatever ball you have drawn, that is find the probability of that ball from the bag 1, then you are able to find. But what I am asking? I am asking that what is the probability that the red ball that you have drawn, suppose the event of drawing a red ball is A, okay, and bag 1 represents the event 1, bag 1, and E2, bag 2, okay. So what is my question? My question is that the red ball you have drawn, this event completed. Now what is the probability that the red ball that you have drawn, it is drawn from the bag 1? This is the question. It means that you have to find P E1 by E. Here what you have found? Here you have found P A by E1. Here you are finding P A by E2. But here what you are finding? You are finding the probability of the ball which is red, which is drawn, is from bag 1. It means you are trying to find probability of the bag from which we get the red ball. Got it or not? So So right now we are unable to find this because I have not described here the base theorem. These kinds of questions will be fulfilled or the problems will be solved using the base theorem. Got it or not? So see, before going to base theorem, some basic things are there which is directly associated with the base theorem. So that is the thing that I am going to describe first. So the first thing that we will go through in base theorem is partition of sample space. Partition of sample space. Partition of sample space. So if you are starting base theorem directly, don't study. Never study base theorem directly. First you have to understand the topic, what is partition of sample space. Okay. So first of all I am going to write about what is partition of sample space. A set of events E1, E2, E3 up to En represents a partition of sample space is a set of events E1, E2, E3, En represents a partition of sample space is if three conditions are there. Condition number one condition is that EI intersection EJ should be equal to phi. It means that between any two events there should nothing be common. It means E1 intersection E2 is phi, E2 intersection E3 is phi, whatever you are taking. But here one condition is there that I will not equal to j. It means that you can't take like that E1 intersection E1. No. E1 intersection E1 is E1. So you are not taking anything common. So it means that this number should be different. Got it? And another thing is that the value of I and j will be equal to 1, 2, 3, up to n. You can take up to n values. So this is the first criteria for partition of sample space. Number two is that union of I equal to 1 to n ei should be equal to s. What is the meaning of this? You are understanding? It means that E1 in union E2 union E3 union up to En is equal to s. In short form I have written like this. I can write here, which implies E1 union E2 union union En equal to s. It means that when all the events from E1 to En will take together, it will form the sample space S. Got it? Now the third point is that probability of each event should be greater than 0. Means in short form you can write like that: PEI should be greater than 0, where I equal to 1, 2, 3 up to n. Is it clear?
Yes, sir.
Have you noted?
Yes, sir.
Now the same thing I will describe through a figure. Same thing I will describe here. See, suppose this is a sample space. This is a sample space S in which some events are there like this. Suppose this is E1, this is E2, this is E3, this is E4, and Suppose this is En. This is events are there. But what you are seeing here that this is a sample space. I have made a boundary of each event, and you will see that practically you will see that there is nothing common between E1 and E2. Can you see it? Is there anything common between any two events? E1 intersection E4. Is there anything common? Nothing is common. So, if different kinds of events are there, but they are pairwise disjoint. Pairwise disjoint means if you are taking a pair of any two events and if there is nothing common, it means that they are disjoint. Got it? So, if they are disjoint, it means that they are making a sample space. So that is the first condition here that I have written, that E1 EI intersection Ej equal to phi, and I is not equal to j means I and j. So suppose if you are taking here 1, you can't take here 1 because I and j will never be equal. E1 intersection E2, E1 intersection E3, E2 intersection E1, whatever you can take. It means that whatever two events, if you are taking any two events randomly, there will be nothing common between them. That is called this EI intersection E2. So if this criteria is fulfilling by this, it means that it is making a partition of sample space. Another thing that is there, you can see, if all the events, I will take the union of all the events, E1 union E2, union E3, union E4, union dot 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 up to En. Then what it will make? It will make sample space or not? That why I have written here, see, in the symbolic form I have written union I equal to 1 to n, EI equal to sample space. Clearly understanding or not? And here I have described, expanded here, E1 union E2 dot 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 up to En, it is making sample space. And third thing is that, see, if there are many events, all the events are such that some elements will be there in them. It means that each element will have non-zero probabilities. Non-zero probabilities means there the probability should never be zero. It means that probability of each event must be greater than 0. Clear? That's why in third points you will see that what I have written PEI greater than 0 and the value of I you can take from 1 to n. Clear, you are understanding or not? Yes, so this is the clear concept of partition of sample space. In further when you will go in base theorem, it will be directly used there. Understanding or not? Yes, sir. I think it is clear. Yes, sir. So now I am going to discuss theorem of total probabilities, right? It is also associated with the base theorem. So before going to base theorem, you have to understand this. Right now what we have studied? We have studied about the partition of sample space. Now let us see what is theorem of total probability. Let E1, E2, E3 dot 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 En represents a partition of sample space and A is any event with non-zero probability and associated with sample space S. Then probability of A equal to summation I equal to 1 to n where I equal to 1, 2, 3, dot 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 up to n. Clear? So this is the theorem of total probability in which this statement is given. Now I will prove how this formula is coming. Total probability will be summation I equal to 1 to n PEI into PA by EI. How this formula will come? Now I am going to prove it. Okay? Have you noted this?
Yes, sir.
So first of all, I would like to describe the statement that I have written through a diagram. See, this is a diagram. This is a sample space. Again you will see that E1, E2, E3, E4 and so on, En are the joint sets which are making the partition of the sample space. Right? Suppose A is any event associated with the sample space S. So we have to find what will be the total probability of this event A. So here you will see that the total probability of A will be what? Practically you can see here. You will see that in the event E1 and event A, this part is common. So this part is nothing but P intersection E1. P intersection E1. Got it or not? If here you will see that in the event A and event E2, this part is common. So what is this part? This part is nothing but P intersection E2. Clear? Similarly, this is P intersection E3, this is P intersection E4, and this complete, this is P intersection En. It means that this total probability of event A is equal to probability of, sorry, here I have written P, here we have to write A, right? So probability of A intersection E1, A intersection E2, and you have to take the union, then you will get the total, right? So what is the probability of total probability to what? PA, P A intersection E1, A intersection E2, A intersection E3, A intersection E4. Then when you will take the total union of that, then you will get this total PA. Clear? We are understanding? So now I am going to prove this. Proof is, can we write A as A intersection or A intersection S? Can we write A as A intersection S?
Yes.
What I mean to say that this is the sample space S and this is completely A. So if you take the intersection of A with S, the result will be this. Got it or not? Do you want more examples? If yes, see. Suppose S equal to 1, 2, 3, 4. This is sample space. Okay. Now, if A equal to 1, 2, then if you take A intersection S, what you will get? If you are taking the intersection, what you are getting? You are getting 1, 2 because you both same thing is matching. So 1 comma 2 is what? Nothing but A. Understand or not?
Yes.
It means that very easily we can write A intersection S equal to A. We can write very nice. Now you see. So which implies A equal to what? A intersection S. And S is what? S is the sample space. It means that it is union of all the events. So it means that we can write here in place of S, we can write E1 union, E2 union, so on union, En. Can we write? Okay. Now, can we write this as A intersection E1 union A intersection E2 union union A intersection En?
Yes, sir.
How? By using the distributive law. This is called distributive law. By distributive law. Am I clear to you?
Yes, sir.
Now you tell me, you will take probability both sides, then we will get PA equal to P A intersection E1 union P A intersection E2 union P A intersection En. Can we write? Is it clear up to here? Is it clear?
Yes, sir.
Now, see. Now what I will do? Now you know very well that since EI intersection EJ equal to phi, where I is not equal to J and Ij equal to 1, 2, 3, ... Right? We know very well all the events in the sample space which make the partition of the sample space are paired by disjoint. Okay? So if EI intersection EJ equal to phi, it means that A intersection E1 comma A intersection E2 comma ... A intersection En are also disjoint. Understood or not? Because if E1 intersection E2 is phi, then E intersection A intersection E1 and A intersection E2, if you take the intersection in both, then nothing will be common. What I am going to say? See, I am going to say that, as I have told you, see, don't be confused. See, suppose this is A, this is E1 and this is E2. Clear? So this shaded part is A intersection E1 and this shaded part is A intersection E2. You can see here practically, is there anything common between this shaded part and this shaded part? No, nothing. That's why A intersection E1, A intersection E2, if you take in a pair, these all are also disjoint shapes. Got it?
Yes, sir.
So it means that here we will write, after writing this, which implies this PA will be equal to PA intersection E1 plus, we will take the sign of plus in place of union. P intersection PA intersection E2 plus ... P A intersection En. Clear? Any confusion?
No, sir.
No confusion is there. So after that, Have you noted? Okay. Now, what can we write this? See, one thing I want to show you here. Since A by E1, suppose I am taking an example here only, so that I can further move. This is the conditional probability. PA by E1 is what? PA intersection E1 by P1. What it means that PA intersection E1 can be written as PE1 into PA by E1. Can we write like this? I have just cross multiplied, nothing. This is called the multiplicative rule. Okay? So multiplication rule I have written, which implies we can write here PA equal to, this can be written as PA, I am writing fast, PE1.
Good afternoon, everyone.
PE1
All of you stand up for the prayer. Join your hands, close your eyes, and repeat the prayer. Oh God,
this is P into P, A by E2, in dot P E n into P A by E n. Got it? So if you will write in summation form, then you can write it like summation I equal to 1 to n, and this will be written as P E I into P A by E n. Got it? Clear? Thank you. We will meet in the next class. Okay?